Hi, welcome back to Math with Miss Grundy. Today we are going to talk about unit rates as fractions. This is probably the third or fourth time that I have re-recorded this video, so hopefully the third time will be a charm and I'll be able to get this posted so that if you are having trouble with your review, this that we're about to do is similar to question number 2 and question number 3. I am going to show you how to find unit rate when the numbers given to you are in fraction form. And I'm going to show you how to do this in multiple different ways, 3 different ways, and then you choose the way that works best for you. I'm going to show you them in order from what I like, the method that I like the most, and then work down to the method that I like the least. And then again, you choose which way you like the best. So when talking about unit rate, we first, before we even find it, need to understand exactly what it means. So unit rate means in the quantity of 1. So it's a ratio that we have scaled up or scaled down, so that it is a quantity of 1, with the quantity of 1 always being the x value. And therefore, whenever we scale up or down our ratio into a quantity of x value being 1, that would mean that our unit rate would then represent our y value. So we're going to go ahead and jump into our first problem. In our first problem, we have Bryce, who is riding his bike, and Bryce can ride 1/3 of a mile in 1/9 of an hour. And I know that my hours is my independent, or my x variable, or value. And the reason I know this is because the longer Bryce rides, it will change the amount of miles that he's able to do. Or the shorter time Bryce rides his bike will then determine exactly how many miles he can go. So the miles would be the y value. Alright, so in order to solve this, I'm going to go ahead and start drawing the tape diagram. So I know I have miles, and I know I have hours. And I know my hour quantity needs to be 1 hour. So I have to figure out how many miles he can go in 1 hour, or how many miles per hour. So I'm going to go ahead and draw the start of my tape diagram to represent what I already know. And what I already know is that in 1/9 of an hour, he can go 1/3 of a mile. And I know that I have to figure out how far can he go in 1 hour. So I'm going to go ahead and draw my tape diagram. It is so sunny that it is a little bit hard to see. But I'm going to go ahead and draw my tape diagram at the bottom. And I'm going to split it into 9 different pieces, because this piece represents 1/9. And I know I have to have 9 of those to make a whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. And each piece is the same, so each piece represents 1/9. So I'm going to go ahead and label each piece 1/9. As the sun keeps getting brighter, it gets harder to see the video. Sorry about that. Alright, now I'm going to go ahead and extend the miles. And I know that 1/3 is how far he goes in 1/9 of an hour. So I'm going to extend these bars up. And each 9th should match with 1/3 of a mile. So I have each 9th matching with 1/3 of a mile, and now I'm going to count up the number of miles. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, aka 2, 7/3, 8/3, 9/3. So he can go 9/3 miles in 1 hour, which is the same thing if I were to take this and simplify it. 9/3, or 9 divided by 3, is 3. So he can go 3 miles per hour. Alright, I'm going to go ahead and show you the second way. Ooh, it is so sunny. This is so hard to see. And that second way, or my second favorite way to solve these, is to create a table. I 100% know that I have hours as my independent because the number of hours will change the distance that he is able to go. So the number of miles he goes depends on the number of hours. And I know in 1/9 he goes 1/3. I know that in 2/9 he will have gone 2/3. I know then that 3/9 he will have gone 3/3 of a mile, or 1 mile. I'm going to continue to extend my chart down below. So I was on 3/9, and that's 3 out of 3 miles, or 1. 4/9 would be 1 1/3 mile. 5/9 would be 1 2/3. 6/9 would be 1 3/3, or 2. 7/9 would be 2 1/3. 8/9 would be 2 2/3. And then finally 1 hour, or 9/9 would be 2 3/3, or 3. So notice how we got the exact same answer. In 1 hour he will have gone 3 miles. The next way that you can solve this is by taking the distance that he goes, 1/3, and dividing it by the time it takes, so 1/9. I'm going to go ahead and change this into multiplication and take the reciprocal. So 1/3 times 9/1, multiply across. 1 times 9 is 9, 3 times 1 is 3, which is equivalent to 9/3, or 9 divided by 3, which equals 3 miles per hour. So either way, we got that 3 miles per hour. Alright, so what happens if they are not 1/3, 1/9 easy fractions to work with? So this time we are going to say that we have a turtle and he can go 1/4 of a mile in 2/5 of an hour. So again, I'm going to go ahead and draw my tape diagram, knowing that I need my hours as the independent and miles as the dependent. So miles, he can go 1/4 into 1/5 of a mile. So now I need to figure out the rest of the hour. So I have 2/5. In order to make a whole 1, I need 5. So 1, 2, 3, 4, 5, and label them 1/5. And I know that in 2/5, so here's 2 more fifths, he can go 1/4 of a mile. Which means I need to find what this piece is, or what 1/5 is worth. Well, if 2/5 are worth 1/4, then I need to take and divide 1/4 into 2 pieces. So again, I'm going to like to multiply instead of divide. So I'm going to multiply and take the reciprocal of 2, which is 1/2, and then multiply across. 1 times 1 is 1. 4 times 2 is 8, meaning that 1/5 is worth 1/8. And really quickly, I don't like these all being different denominators, so I'm going to change just my miles, because now I've figured out how many miles he can go in 1 hour. So I'm worried about now putting them all together. So I am going to look at 1/8 and 1/4 and say, what can I multiply both of them to? I can multiply both of them to 8. So they're both multiples of 8. And I know that 1/4 is equivalent to 2/8. So now that I have them in the equivalent denominators, I'm going to add them all up. So 2/8 plus 2/8 plus 1/8. So remember, whenever we're adding fractions, we just add the numerators and keep the denominator the same. So I have 2, 4, 5/8 of a mile per, and this represented my hour, so per hour. Again, I could use the same second method to do this, and that was a table. So again, my independent is hours because it affects and changes the amount of miles that the turtle can go. And I know that in 2/5 of an hour, he can go 1/4 of a mile. Therefore, in 4/5, he can go 2/4 of a mile. And now I have to figure out 5/5 or 1. So before I figure this out, I need to figure out 1/5 of a mile. Well, if this is 2/5 and this is 1/5, that's half. Half of 1/4 is 1/8. So now I could take the 4/5 and the 1/5 and add them together to get 5/5. Therefore, I would have to add my 2/4 plus my 1/8. 2/4 plus 1/8, or 4/8 plus 1/8 is 5/8. So here's my unit rate, where x is 1 and my y is the unit rate. So 5/8 miles per hour. The third way that we did the last one, and that we're going to do this problem as well, hopefully the sun doesn't change too much, is 1/4 divided by 2/5 hours, because I want to get the number I'm dividing by should be the number I want down to scale up or down to 1. So I'm going to multiply and take the reciprocal, so 1/4 times 5 over 2, and then multiply across, so 5 over 8, add my units, mile per hour for the unit rate. For the rate. Unit rate would just be 5/8. Either of the three methods that you choose, you end up getting the same answer, 5/8 miles per hour. And that is how we find unit rate with fractions. If you have questions, comment below. Like, subscribe, do your math homework, study. Watch the previous video that I uploaded on Thursday to help you with your review. And I will see you all tomorrow. Have a great rest of your weekend.